Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 113th of physics, and in today's lecture we are going to learn the technique of measurement of EMF and potential difference. In the previous lecture, we learned in greater detail between and differentiated between the two terminologies EMF and potential difference. Now it is the turn of measurement of EMF and potential difference. Before jumping into the world of measurement of EMF and potential difference, let me explain first that this device is used for measurement of both the potential difference and the EMF. How we will learn in this section. So, the EMF of a source such as cell can be measured approximately by a voltmeter connected directly across the terminals of the source. It means that we have to connect the voltmeter in series if we want to find the EMF of the dry cell. And as you can see that in the given figure on your screen, that positive terminal of the voltmeter, which is red in color, is connected to the positive terminal of the cell. Similarly, the negative terminal of the voltmeter is connected to the negative terminal of the battery. The negative terminal is always denoted by a black wire, and the positive terminal is denoted by a red wire. So, when we connect a voltmeter directly across the terminal of the source as shown in the figure, we will be able to measure the EMF, electromotive force. The figure shows the circuit diagram for finding the approximate EMF of a cell in volts. Note that the current I is usually very small, flows into the positive or red terminal of the voltmeter and leaves by negative or black terminal. Note also that the positive terminal of the cell is connected to the positive terminal of the voltmeter, and the negative terminal of the cell is connected to the negative terminal of the voltmeter. To measure the potential difference, to measure the potential difference in volts between 2 points separated by a load, the voltmeter is always connected in parallel to the load, such as the resistor. And about the resistors and resistance, we will talk in the next section today. Dear learners, the main difference between measurement of EMF and potential difference is that when we want to find the EMF of a dry cell, we have to connect the voltmeter in series. On the other hand, if we want to find the potential difference, we have to connect The voltmeter in parallel is shown in the figure. As I told you earlier that both the potential difference and EMF are measured by one device called voltmeter. Another device which is also used is called ammeter as well. But mostly we are using a voltmeter. An ideal voltmeter must have resistance, which we will discuss in the next section, very much larger than that of the load of resistance R. Yes, you have to keep in mind that the resistance of the voltmeter must be very much larger than that of the load resistor it is connected across. This is to avoid drawing a large current from the circuit it is connected to. If the uh, resistance of the voltmeter is much more than the load, which is this one in this case across, and you can see that there is A and B points. So the voltmeter is connected in parallel to that. The resistance of this voltmeter must be larger than this load, so that we will draw much current, greater current than it what should be. Remember that an ideal ammeter, on the other hand, must have a very much lower resistance compared to that of the load, so that the amount of electrical energy dissipated is very small. In this manner, the current I flowing in the circuit will not be smaller than what it should be. Yes, in one case, the resistance of the voltmeter must be greater than the load, and in the second case the resistance of the voltmeter must be lesser than the load when we are measuring the EMF and potential difference respectively. Uh, Dear learners, now we are turning our focus to another very important topic, and that is resistance. The opposition provided by the lattice atoms in a conductor to the flow of free electron is called resistance. In other words, resistance is a property of a material that restricts the movement of free electron in material. Let me discuss that first to you people. If there is a conductor in which there are free electrons, and these electrons are moving in the conductor to produce electric current. Now there are lattice atom. Let me make it with the another color. These are the lattice atoms which is vibrating like this, up and down. There are situations in which many free electrons pass through these lattice atoms. So in this case, the current will be less. If there is a resistance, means opposition to the flow of free electron, and if the opposition is larger one, then few electrons will pass through these barriers, through these barriers, and as a result we will get less current. If there is less resistance to the flow of free electrons, then it means that many electrons will pass through these lattice atoms, and as a result we will get larger currents. Dear learner, if we are using copper wires, then there is less conductors, less resistance, and we will see the flow of electrons very frequently, and we will get good results of a current. But if we are using other types of conductors, then we will not be able to see the good result of electricity. So if we are using copper wires, we will save the electricity because there will be less resistance. One thing more I want to clear here, that when voltage is given to this electron, means that they are pushing this electron, so it means that this electron is getting an energy, and due to that energy this electron is moving in the conductor. But if this lattice atom is providing a position and stopping this electron from moving freely inside the conductor, then the question arises in the mind that where that energy is going. That energy is going out from the wire in the form of heat, and you know that heat is a form of energy. Whenever you are feeling that the wire is hotter, when the current is flowing inside that conductor, then you must have to understand that there is a lot of resistance inside this conductor. On the other hand, if the wire is feeling colder, then you must have to understand that there is a less resistance inside this conductor. So the resistance determines the size of current which can pass through the material. Now if we want to compare this with the mechanical fraction, then they are the same. Means this property is similar to mechanical fraction for moving object. They are also providing the opposition to the flow of object. Now the next question is the measurement of resistance. The resistance of a material is defined as the ratio of voltage and current. Whatever is the ratio between voltage and current, we are saying that this is the resistance. Remember, the SI unit of resistance is the ohm, and this is the symbol used for ohm. Now what is 1 ohm? 1 ohm is the resistance of a material through which a current of 1 ampere flows when a potential of 1 volt is maintained. Remember that if we are fixing a camera here on this point and we are saying that 1 ampere current is flowing here in this area when 1 volt of potential difference is given to these free electron. So we are saying that 1 ohm resistance is there. When 1 ampere current is flowing, when 1 volt of potential difference is applied to the electron, then the resistance will be 1 ohm. Remember this. Here in this case, V is the potential difference across the material and I is the current flowing through in it. R is equal to V divided by I. So remember, from this, in tomorrow's lecture we will discuss a very important law, that is the soul of electricity, Ohm's law, which can be derived from this one. So 1 ohm is equal to 1 volt per 1 ampere. It simply means that when 1 volt is given and 1 ampere current is flowing, then the resistance will be 1 ohm. Now, the last topic for today is types of resistors. Any conductor that is used to provide a known value of resistance in a circuit is called a resistor. The primary purpose of resistor is to control the size of current flowing in the circuit. Let me explain it in very simple way. If you are seeing the motherboard of computer or any electronic devices, for example, there is an IC and there is another device which is the condenser, or that is the capacitor. The current is coming from this device and this is, for example, 6 volt, but we need here 2 volts. So there must be a mechanism to stop this 6 volt reaching the IC. So for that particular purpose, we will introduce the resistance. So resistance will control the flow of electron and as a result we will get the less amount of voltage. Similarly, for this we have to provide, for example, more resistances, because this required, for example, 1 volt. So we have to introduce these resistance. These are called fixed resistances. There are 2 types of resistances. One is called the fixed resistance and the second one is called the variable resistors. Very technically, they are also known as rheostat. The range of resistance for resistors varies from less than 1 ohm to several mega ohm depending on their use. Ladies and gentlemen, the first category of resistors or the first category is the fixed resistance. And fixed resistance are of four types: carbon film resistors, carbon composition resistors, tin oxide resistors, wire wound resistors. These are shown inside the figures. These four different types of resistance are shown on the right side of various resistance. Remember that for uh, fixed resistance we are having this symbol, as we have learned that in the table of symbols of devices. The second type of resistors is variable resistor. A variable resistor or rheostat is included in a circuit to vary current flowing in it. The figure shows a rheostat commonly used in laboratories, while the other two figures are the original one. This is the schematic diagram, and these are the original diagrams of rheostat we are using commonly inside the laboratories. One thing more before finishing, that these are the symbols used for variable resistors. Now, if we are changing the station in radio through a knob, that knob is connected to a variable resistances, and that is called rheostat. By changing the resistance we can produce different current and different channels. So these type of resistance are mostly used in radios. With that we came to the end of this topic. Tomorrow we will learn how to determine the resistance of a load and the current voltage characteristic of various materials and Ohm's law. So stick to this channel. Don't go anywhere from this channel. Thank you very much for your time. Allah Hafiz.